This episode of Unconventional Engineering is powered by Twinify, the digital twin solution built to unlock the value of your data.
Hello, and welcome back to ASME's podcast, Unconventional Engineering. I'm Tom Costabile, ASME's Executive Director and CEO, along with my co-host, Christine Reilley, Managing Director of Strategy and Innovation here at ASME. Hi, Christine. What have you been up to lately?
Hi, Tom. Well, my team and I have been continuing to explore opportunities for ASME in areas like clean energy. So one of the exciting areas we are looking at is small modular reactors, among others. But it's been fascinating for us to delve into these topics for ASME.
I would agree, Christine. I really appreciate what you and the team have been doing between SMRs, our conversation today, which will dip into hydrogen a bit. It's an exciting time, and I'm glad you guys are doing it.
We are too.
So, Christine, tell us, who do we have in store for our audience today?
Hey, well, Tom, the topic of renewable energy has certainly taken the world by storm, no pun intended. And so in addition to solar, wind, geothermal, SMRs, there's another element that is coming into its own within the context of the conversation surrounding net zero emissions. And that element is hydrogen, as you just mentioned a few seconds ago. So please welcome our guest, Matthew Blieske, CEO of LIFTE H2, who will hopefully shed some more light on this emerging energy source for us.
Pleased to be here.
Thank you. Great to meet you. So, Matthew, I understand that your company is what's known as a hydrogen supply chain integrator. What exactly does that entail?
I get that question a lot. And the state of hydrogen right now is that, there is no grid. So when you look at wind and solar, some of the other energy industries, when we think about clean tech, it was enough challenge just building the solar farm, right? Finding the inverters that work with the panels and figuring out how to work through the codes and standards, and then figuring out the business model around a non-dispatchable asset, right? It's not like a peaking plant where you can turn it on and off. So these were all challenges enough. But then at the end of the day, when you figured all that out, there was a grid that you could plug your system into and then bring your product to market through that established grid. That grid does not exist for hydrogen. And so just simply making hydrogen is not enough, and just simply building a refueling system or an end use isn't enough. You have to figure out how to move that product, store it, bunker it, trade it, all these other things that really make an attractive energy product. So there are pieces of that, right, where you have technologies all along that chain from production to midstream to downstream, and you have pieces of the services here and there. The regulations, codes, and standards are there, but not necessarily ubiquitous or well understood. And so at the end of the day, the end customer who wants to buy hydrogen, it's very challenging for them to do that without an integrator, a supply chain integrator, right? They want to buy hydrogen like they're buying diesel today, or like they're buying methane, or like they're buying their kilowatt hours, right? They want to procure it. So if you don't have a contiguous chain, then that's very difficult to do. And so what LIFTE H2 does is we have our own products. We have integrated services. We partner with others who have complementary products, and we build from the electron to the end user end to end. So it's all integrated. The interfaces are well managed, and really at the end of the day, the customer gets what they want, right? And that's what we think about system integration on the component level, but really there's another level needed here, and that's across the full supply chain. And that's really an artifact of a new industry. This will become very standard of how this is done eventually, but it's going to take some years to kind of write those rules before everyone knows how to bake that cake.
Matthew, thank you for that. I'm curious, what's the genesis of the name LIFTE H2?
Yeah, it's a great question. So LIFTE is an acronym. It stands for Love, Integrity, Fun, Truth, and Excellence. And so that's if you look at the logo, it's that's what you see, and the H2 is a small part. Hydrogen is kind of what we do. It's what keeps the lights on. It's certainly our technical passion. But at the end of the day, these are the things that how matters more than what for us. There's lots of examples of good intentions producing bad results. And so for us, the path taken is even more important than where we end up, because we know if we're adhering to these values, it is a values-driven company, then in the end, we know we'll get where we need to go. And I think my personal environmentalism is around, the planet will be fine. The planet will be here. It's the people that matter, right? This is really about better lives for people, protecting people, in other worlds as well, right? It's the same planet. And so our solutions, and this gets, just driving it back home, is that our solutions have to work for the everyman, right? Our solutions have to have an impact to people who can't afford Tesla Model S's, right? And so things like we have archetypes that work on, bus fleets, transport corridors. So, people living next to these, coming out of Port of Long Beach is just a horrendous particulates issue in the air. Things like this really matter for us. And so you see our solutions are driven by that. And I think different people come to it from different angles. For me, this was it was an expression for my faith in Christ. And for other people, this is, it is just kind of like a rallying flag around these values that are just drive already in the young part of the company. It's driven very different decision making, and it's actually, I think, the reason why we're around and thriving still in a very challenging industry.
Well, thank you. So off mic for a second, Christine, why don't you pick up on the next piece? I think Matthew captured everything.
Okay. So Matthew, how exactly does your team get involved, whether from a strategic consulting standpoint or as it pertains to actual product development?
Yeah, so we are a solutions company. So we do have products and services. And so what we do is fill the holes. We think of ourselves as the mortar and the bricks, so to speak. So what we often get brought in is after, so a developer will have tried to develop the project, realize that this isn't wind and solar, for the reasons we already talked about, or come from the other side, where if you have an oil and gas background and you realize that a standard EPC or the standard ways of kind of working, yes, hydrogen is a gas, and yes, lots of hydrogen is made behind the fence line, so to speak, in big industrial processes, but we're talking about very different kind of energy systems. And then that's usually where we're brought in, because we have those solutions and those products, but also the products that we don't develop ourselves. We have deep industry experience with other technology providers that we can bring in and just at the end of the day produce a top level result. Is the so what, right? It's the dollars per kilogram, it's the reliability, it's safety, and it's not disrupting operations at the top level. And so that's usually where we're brought in. And this is a journey. I think the hydrogen industry, the first project is in a particular archetype, be it either industrial blending or a fleet heavy fleet project. You're not going to be making 15% returns on the very first one, right? It's going to be a roadmap to that success. Now, the good news is that there are innovations and efficiencies that have been gained over the past decade where you can make money off of hydrogen, and there's a pathway to get to something that looks a lot like wind, right? If you look at, say, 20 years ago, wind was and solar were in the same boat. There was a production tax credit and investment tax credit. And now hydrogen has the same thing. So we're at the front end of that journey. And so we have all the elements in place. And usually that's where we're brought in to kind of help pull all that together to get that project across the line.
So Matthew, to that effect, what does the hydrogen adoption picture look like in the U.S. marketplace and versus Asia and or even Europe? And I know as we're doing this, you're actually in Europe this week. Tell us a little bit about what you see that adoption would be.
Yeah, what's interesting from a technical perspective is that I've had a career with a major oil and gas company working in their hydrogen group, and you saw people learning the same technical issue, learning the same things over and over again across the globe. And so there's a lot to be learned on the technical side of things by sharing. You don't have to relearn those same mistakes. But exactly which industries, so anyway, there's a good case there to be made with collaborating across nations. And I know that, in Germany, there's a number of organizations that work with the DOE, and same with Natural Resources Canada, and Japan, Korea. There's a lot of good collaboration there. Brazil, and Chile. But then the business models are different, right? Because the subsidy schemes or what our natural strengths are different. So, for example, in Europe, it's really about energy security and security of supply, right? So finding where are you going to go get that hydrogen from. So there's a lot of emphasis on moving vast amounts of hydrogen into Europe and around Europe, and kind of solving that big hairy problem. In the US, it's a little different because of there's a lot of cheap energy, a lot of cheap access to energy, and there's more to be had, right? More solar to be built, more wind to be built. There's gas fields that we can sequester. And so it's really just more about how to scale that production, and then build the demand. And there's so much existing oil and gas resources that can be repurposed that it's kind of taking it from a different angle. And in China, they're taking it a very different way. I actually had the opportunity to build a couple of projects in China before forming LIFTE H2. Their challenge is very acute. It's pollution, right? They have a real big pollution problem, and so it's not so much necessarily about, say, global warming, but it's about now, right? People are dying from lung diseases there today, and so they have a very accelerated program to get thousands of trucks and tens of thousands of cars on the road to leverage wind in the western part of the country. And so it's a program on a massive scale. But what's interesting is that all of these programs tend to rise the tide together, right? So if there is advancements in a program for pipeline retrofit in Europe, that benefits the US, because that technology and those suppliers can supply that into multiple regions. And that's our approach as well, that our products are global and the services are local. And I think that's what we see in hydrogen in general, right? That what we may not see locally, if you just kind of walk out your door and look around, you say, well, where's the hydrogen? Well, it can come a lot faster than you think, just simply because of what's going on globally, right? Localizing that benefit is something also that we focus on, right? Taking, for example, projects in mining around the globe can benefit heavy duty trucking. Why? Because they're similar products, right? And so you don't have to start from square one, I guess is what we're saying. There's decades of learning and experience there, and just a hyper amount of growth in the past even 2 or 3 years on the products and services side that can be leveraged without having to go through that pain.
Matthew, one popular topic at ASME is that of the engineer's lifelong journey. What has your career arc been like?
Unpredictable. I actually started life as as an aviator, transitioned into engineering. I was an aerospace engineer working in the aerospace industry, and then just really kind of, for me personally, I saw aerospace as kind of at the tail end of the S curve of innovation. It was had its heyday in the middle of the last century, and moved into the legendary aircraft like the SR-71 and the space shuttle, and all of these kind of things that some of us have posters of when they were little on the wall, and maybe still do. And for me, I thought, I didn't want to, I wanted to be in uncharted territories. And so the energy systems of even the present, right? I spent a while in oil and gas as well. I think we do have to appreciate the fact that the reliability and safety that we have from our current energy infrastructure does need to be appreciated and applauded. And there's a lot of really interesting problems to solve there. And that's what really kind of turned my crank around different, really gas turbine systems and tri-generation systems and, storage systems and energy storage systems and things like that. And that's been my journey of it didn't start in alternative energies. It started in more conventional energies because there were really interesting uncharted problems to solve. But then it was obvious that this is the frontier. This is the thing that no one knows exactly how this is going to end up. And so that's always, I think, the common theme for me of what's driven me, and really a move for me personally away from deep discipline engineering and more into systems engineering. So solving systems problems on individual components or pieces is where I kind of got into, and then now we're solving the system of systems problems, because our systems are so complicated that there's the detailed design, then there's the system design, and then now there's the system of systems design, which is really what LIFTE H2 focuses on. And as we get more and more complicated systems, the layers just keep going and going. And so I find it really exciting. It's tough to communicate that complexity. And so it's communication and a collaboration is a skill that is going to be more and more important for engineers, because just simply the days of sitting down and designing something and saying, here it is, are gone, because that thing doesn't produce the value that you think it will in isolation, right? So you have to be able to integrate it, not just with the thing upstream and downstream of it, but also up and down, right? The higher level context and the lower level context to produce value, because we're moving into brave new world of complexity, and you see it all across the world, like ChatGPT introducing another level of complexity in computing, and energy is no different.
So Matthew, you mentioned communication. Is there any other advice you have for engineering students, early career engineers, or even those who have been in the field for some time?
I do, certainly for early career engineers, and maybe holds true for later as well. And I always say, do something. I actually had a kid while I was working at my last company come in, and I think he was angling for a job, and he was clearly graduating from a very prestigious engineering school. And I think he was pretty proud of himself, of his marks and whatnot. And he said, well, what advice would you give? And I said, well, you should go and do a job that scares you. And what I mean by that is, at the end of the day, what does it mean to be an engineer, right? It means that you are designing systems for the public good, and most often, those systems have public safety, to be thinking of, security, reliability, right? Power goes out, people can freeze, or you're designing a car, right? Obviously, safety is a big thing there. I remember one of the first jobs I had was designing repairs for an A320 fleet in Air Canada, right? And that was that was a bit scary, right? Designing repairs that need to fly. And the reason why I mention that is be it either if you're a software engineer, environmental engineer, whatever it is, right? Do something that's, to say it a different way, do something that's impactful and meaningful, because something that's impactful and meaningful is always have risk associated with it. It has either, financial risk or public safety risk or reputational risk, right? And I would say, go do that young, because if it's harder and harder to gain that experience when you're older, because the stakes get higher and higher. And so when you're young, you kind of have this, you get to train under someone else, it's not your fault, this kind of thing. And so go do that stuff, get out in the field, go touch systems, go write code that, moves real things. Because that has made all the difference for me, right? It's, sticking your head inside of a gas turbine in Mozambique, or repairing, getting called at 3 a.m. to go repair some guy who put a forklift through the side of a cargo plane, things like this, right? It's just, it's fun. It's some would say it's, it can be stressful, but I mean, I think from an engineering perspective, that's what we signed up for, I think, right? It's to make real things work. So don't shy away from that. because that's that's kind of I think what separates engineers from some of the other professions out there.
I love your analogy of forklift through an airplane. So, that's why they invented duct tape, right?
That is not an analogy. That is something that really happened. So we actually, in the industry, we call it a 900-mile-an-hour tape.
Yeah.
So it's a aluminized tape that you can put over certain sized holes that lasts, that flies. So, it's tape that's good for 900 miles an hour.
Well, Matthew, Christine, I'm afraid that we're out of time, but I want to thank you, and I want to thank everybody for listening to this. I'm intrigued, Matthew, and I wish you and LIFTE H2 the best of luck. We should stay in touch and do this again in the near future as you completely evolve. I was interested to hear you say that from a technology standpoint, it's not a challenge. Being an engineer, I learned a long time ago, if it's too simple, we stop, do it over again, we make it harder just because we can. And then you're spot on. A lot of what I've been seeing and a lot of colleagues I've been speaking with, it's all about negotiations and how do you get people to the collaboration table. I tip my hat to you, sir. I think you've got a winning combination here. Well, Matthew, thank you again. Christine, thank you again. And again, as always, I would encourage anyone out there that would like to suggest a topic or a guest or just to say hello, be sure to reach out to our Unconventional Engineering production team or email us directly at media@asme.org. And if you're interested in becoming an ASME member, log on to asme.org or consider donating to the ASME Foundation at asmefoundation.org. Matthew, thank you. Christine, thank you. Enjoy the rest of your day. Take care, everyone.